Greetings, guardians of dreams. Fall asleep with us, awaken wiser. Today we will embark on a special journey beyond the familiar cosmos. First, we will find ourselves among the first envoys of humanity who forever rushed into interstellar space. We will see the stars closest to us and peer at the red giant Betelgeuse, experiencing the final stages of its life. We will learn about mysterious wandering planets without a star, and we will travel to the edges of the Milky Way to experience the scale of our galaxy, and then even deeper to black holes, masters of gravity, and to the very edge of the visible universe. We will touch on unanswered questions and try to imagine what lies beyond its borders. If you resonate with our atmosphere, subscribe to the channel, get comfortable, wrap yourself in a blanket, and let yourself dissolve into space with this story. Enjoy listening, and good night. Chapter 1: Cosmic Messengers and the Frontiers of the Solar System. Since ancient times, humans have dreamed of leaving Earth and seeing a world beyond the familiar sky. At first, it seemed impossible. The sky was an endless dome, and no one knew what lay beyond it. But over time, we learned to build telescopes, send rockets, and one day, the first human-made spacecraft launched into space. They became our eyes and hands in places where humans themselves cannot yet go. These spacecraft are our cosmic messengers. They fly where no human has ever set foot, and they carry with them the memory of Earth. Among them were the pioneers, the Voyagers, and the New Horizons mission. Each of them became an important milestone in the history of space exploration. The first step was the Pioneers. In the early 1970s, Pioneer Day flew to Jupiter and showed us its surface close-up for the first time. It became the first Earth-based spacecraft to leave the solar system. Its sister spacecraft, Pioneer 11, headed for Saturn. Today, both of these spacecraft continue their journey through the darkness, though their voices have long since died down. They no longer transmit signals, but continue to fly forward toward stars that will meet them only in many hundreds of thousands of years. Next came two Voyagers. They were launched in the late 1970s. These spacecraft circled several giant planets at once. Voyager I passed by Jupiter and Saturn, and Voyager 2 also managed to fly by Uranus and Neptune. It is thanks to these spacecraft that we learned about the volcanoes on the moon Io. We saw the subglacial oceans of Europa, the rings of Neptune, and dozens of new moons. But the most astonishing thing is not only the discovered worlds, but also the fact that both Voyagers are forever heading away from the Sun. Today, they have left the boundaries of the solar wind and entered the interstellar medium. Voyager I is considered the most distant human-made object. Its path leads toward endless darkness. The Voyagers also have a special mission. They carry gold plates. These plates are engraved with images, the sounds of Earth, greetings in many languages, even music. This is a message to the future, a sign to whoever encounters these spacecraft. There is life here. There is intelligence here. We were there. Perhaps no one will ever find them. But the very idea that humanity has left its mark in space gives these flights a special meaning. A series of space envoys were later joined by the New Horizons spacecraft. Its primary target was Pluto and its moon, Haurun. In the 2000s, it reached its destination and showed us a wondrous world at the edge of the solar system. Icy plains, mountains of ice, and the shadow of a distant sun. But its journey wasn't over. New Horizons continued on toward the Kuiper Belt, where cold and mysterious bodies lurking, preserving the memory of the early universe. These spacecraft fly along hyperbolic trajectories, meaning they will never return. They will continue their journey for millions of years, until they disappear into the depths of space. And there's a special poetry to this. Humanity hasn't yet learned how to build ships for interstellar travel, but our envoys are already there. They are like milestones on a path we have yet to take. Imagine a small metal craft, no bigger than a car, flying in complete darkness. There's no sound or light around. Only a few particles of cosmic dust collide with its hull. Its power source gradually fades, its instruments shut down one by one, and silence descends. But the motion continues. The craft flies through eternity, and there is something majestic in this motion. Perhaps one day, the descendants of humans will develop technologies for interstellar travel. Then, they will be able to catch up with these ancient probes, return them to Earth, and place them in museums as the first relics of our space age. Or perhaps they will remain eternal wanderers, until they are overtaken by a collision with some distant body, or until they dissolve into the streams of time. Thus begins our journey beyond the solar system. The first steps have been taken. They may be small by the standards of the universe, but they are the ones that open the way to the future. After all, each craft is a reminder. Man always strives to go beyond the known, always seeking new horizons. Chapter 2. Our Sun's Neighbors, the First Stars. When we leave the boundaries of the solar system behind, we find ourselves in apparent darkness. At first glance, space appears empty and cold, but this is a deception. Around us is a veritable ocean of stars. Our Sun is just one of hundreds of billions of stars in the Milky Way. And next to it, within a few dozen light years, are its neighbors, other stars, each holding its own secrets. The closest to us is Proxima Centauri. It is a small and dim star, a red dwarf. It is so faint that it cannot be seen with the naked eye on Earth. But it is precisely around it that a planet has been discovered, which scientists believe is similar to Earth. This planet orbits so close to its star that a year there lasts only a few days. Its surface may be cold and harsh, but the conditions on it do not rule out the possibility of water. If we imagine that a person could stand on this distant planet and raise his head to the sky, he would see his star not as yellow, like the sun, but as a dull red, like an eternal sunset. A world under such a sky would look unusual, but that's the charm of alien worlds. A little further away lies another dwarf, the star Ros 128. It is quieter and calmer than Proxima. It is also orbited by a planet named Ros 128b. The temperature on its surface may be close to Earth's. If you imagine this world, it would resemble a cold autumn or early spring. Perhaps there are stony plains, covered with frost, and a dark sky with a dim, reddish sun. Scientists believe that it is precisely such worlds that are most promising for the search for life. There is also Luden star. Unlike Proxima or Ros, it has an entire system of planets. Some of them may be rocky and habitable, while others resemble gas giants. If we could observe the night sky from one of these planets, we would see neighboring worlds shining brightly in the sky, like our Moon and Venus. It's amazing to think that such systems exist so close to us, tiny replicas of our solar system, with their own secrets and mysteries. But among our closest neighbors, there are not only tiny, dim stars. There are also bright stars that we can see even without a telescope. Altair, for example, is clearly visible in the summer sky. This star shines almost 11 times brighter than the sun. It rotates so quickly that its shape is far from a perfect sphere. It seems flattened along the equator. If we lived in the Altair system, its light would be blue-white and blindingly bright, illuminating everything around it with a cold radiance. Another notable star is Fomalhaut. It is surrounded by a huge ring of dust and gas. Scientists call such formations the cradle of planets. New worlds may be being born within this ring right now. When we look at Fomalhaut from Earth, we see only a bright star. But if we were closer, a whole picture would open up before us. a shining star surrounded by a huge ring, like a pearl in a smoky setting. Arcturus occupies a special place among its neighbors. It is one of the brightest objects in the northern sky. Arcturus is a giant star in the late stages of its life. It was once similar to our Sun, but now its envelope has expanded, making it dozens of times larger. If it were at the center of our solar system, it would engulf the orbits of all the planets, all the way to Mars. The light from Arcturus is warm and orange, like an eternal sunset. In the future, our Sun will undergo a similar transformation. Looking at Arcturus, we seem to be peering into the future of our star. A wide variety of examples can be found among the stellar environment. There are systems where stars form pairs or even trios, and then 2 or 3 suns can be seen in the skies of their planets. Imagine a sunset where one sun sits below the horizon while the other still shines above. This spectacle seems fantastical, but in space it is quite real. Sometimes scientists find systems where a star is surrounded by multiple exoplanets. Some of them resemble Earth, others resemble hot balls of gas. Still others are icy worlds. Each new discovery confirms a simple idea. There are far more planets in the universe than stars. This means that almost every one of our closest neighbors may have its own worlds, but for now, they remain out of reach. Even to the closest star, the journey would take hundreds of thousands of years on a modern spacecraft. For us, it's an eternity, but the dream of interstellar travel lives on. Once, even oceans seemed impassable, but man built ships and crossed them. Perhaps one day, we will develop new technologies and be able to cross the interstellar void. Our stellar neighbors are like the nearest village to our hometown. They are not yet reachable on foot, but they are already visible in the distance. And if we learn to travel faster, they are the ones we will head to first. In Proxima Centauri, Scab 128, to Lathan, to bright Altair, to shining Fomalhaut, and to the orange giant Arcturus. Each of these stars reminds us that space is near. It is not only silent darkness, but also a living fabric woven from millions of luminaries. And when we look at the night sky, we see more than just beautiful lights. We see entire worlds waiting to be discovered. It is here, among neighboring stars, that humanity will take its first steps into interstellar space. And while it may be just a dream for now, every dream eventually becomes a reality. Chapter 3. The Mysteries of the Red Giant Betelgeuse. Among the many stars we can see in the night sky, there are some that particularly captivate our gaze. They are bright, unusual, and it seems as if there is more to their light than just the flame of a distant sun. One of these stars is Betelgeuse, a red giant whose fate excites astronomers and space enthusiasts around the world. Betelgeuse is located in the constellation Orion, the very same constellation where 3 stars form the famous belt. If you look at the sky in winter and find Orion, you'll see this bright star in the upper left corner of its figure. Its light is warm reddish-orange, and even with the naked eye you can see how it differs from its cool blue-white neighbors. This star is a true giant. If Betelgeuse were placed at the center of our solar system, it would swallow all the planets up to and including Mars. Its size is many hundreds of times greater than that of our Sun. Yet its matter is so thin that a spaceship could easily fly through its outer layers without encountering impenetrable walls of fire. Betelgeuse is in the final stage of its life. Stars are born, mature, and die. And now we see the giant in its old age. Almost no hydrogen remains within it, the substance that has fueled stars for millions and billions of years. Now other processes are taking place, making the star unstable. Sometimes its light brightens, sometimes it dims. In recent years, astronomers have noticed that Betelgeuse has suddenly darkened significantly. This event has sparked many rumors. Perhaps it is preparing to explode as a supernova. What does this mean? When stars like Betelgeuse reach the end of their lives, they don't fade away quietly like a candle. A grand finale awaits them. A supernova explosion. This is one of the most powerful phenomena in the universe. A star literally tears itself apart, ejecting a huge amount of matter and energy. An explosion of such power could outshine the light of an entire galaxy. Scientists believe that Betelgeuse will indeed explode someday, but it is impossible to say exactly when. It could happen tomorrow, or it could happen in 100,000 years. In any case, for astronomy, this will be the event of the century. Imagine a new bright point appearing in our sky, shining as brightly as the moon. Perhaps its light will be visible even during the day. Should we be afraid? No. Although Betelgeuse is huge and powerful, it is located far enough from Earth. Even if an explosion occurs, it will not be able to harm our planet. The light and particles that reach us will be a stunning spectacle, but not a threat. We will be able to observe the end of a star that has lived for millions of years and witness the birth of new elements. After all, it is in such explosions that heavy metals are born: gold, platinum, uranium. All of these later become part of new stars and planets. Betelgeuse is surrounded by gas clouds, ejected by itself in past times. These clouds create a kind of fog around it. Sometimes, it is these clouds that cause the star to dim, blocking its light. This is how scientists explain the unexpected darkening that occurred several years ago. But the mystery still remains. What is happening inside this giant? We can only speculate for now. Betelgeuse attracts attention not only for its physical nature, but also for its symbolism. Its name comes from Arabic and means the shoulder of Orion. For many people, this star has been a landmark, a beacon in the night. In ancient times, it was used to determine the seasons, build calendars, and myths associated it with heroes and gods. Imagine that one day Betelgeuse flares up. A new bright object will appear in the sky, changing the familiar appearance of the constellations. People will gaze upon it with astonishment, just as the ancients once observed comets and eclipses. And at that moment, we will witness the birth of a new stellar history. Betelgeuse reminds us that stars are alive. They are born from clouds of gas, burn for millions of years, and then die. But the death of a star is not the end. A supernova explosion scatters matter across space, and from it new worlds are formed. Perhaps one day, planets on which life will arise will emerge from the remains of Betelgeuse. Every time we look at that red glow in the sky, we see a star living the last moment of its long history. These moments may last thousands of years for us, but on the scale of the universe, they are merely a fleeting moment. Such is the fate of Betelgeuse, a giant preparing for its final dance. For us, this is an opportunity to witness a cosmic drama in real time. And who knows, perhaps we will be the ones to witness how one day the night is illuminated by the bright light of its farewell explosion. Chapter 4. Lonely Wanderers, Planets Without Stars. We are accustomed to the idea that a planet is inextricably linked to its star. Earth revolves around the Sun. Mars and Venus are also connected to its warmth and light. Each planet has its own path, its own orbit, and all of this is subject to the gravity of the star at the center. But the cosmos loves to subvert conventional notions. Among its mysteries are special worlds that know no master. These are wandering planets, or, as they are also called, orphan planets. Such planets are starless. They are warmed by no light and know no dawn. Their skies are forever dark, and only distant stars shine as pinpoints on the cold horizon. Imagine such a world, a boundless plain of ice or rock, over which eternal night hangs. There is no east or west, no seasons. Only silence, cold, and infinity. Scientists believe that such worlds may be far more numerous than those orbiting stars. Some are formed by cataclysmic events. A planet is born in a normal system, but over time, strong gravitational tugs eject it. This can happen after a collision with another giant or due to a close pass of a neighboring star. Other wandering planets may form on their own as immature stars. They collapse from a cloud of gas and dust, but they lack the mass to ignite a nuclear fire. So they remain eternal wanderers, too big to be mere asteroids, but too small to shine like stars. For a long time, these worlds existed only in theory. How can one notice something that doesn't glow? After all, a planet without a star doesn't reflect its rays. It's almost invisible, but astronomers have found ingenious ways. One of them is infrared telescopes. Even cold planets emit faint heat. Capturing this trace can hint at the existence of a hidden world. Another method is gravitational microlensing. If a planet passes in front of a distant star, its gravity slightly distorts the light. We see a tiny flash, a sign that somewhere in the darkness, an invisible traveler has flickered. The first candidates were discovered at the beginning of the 21st century. One of the most famous was the object discovered by the infrared telescope VAS. It is a world similar in mass to Jupiter, but lacking its own star. Its temperature is so low that it resembled cooled coal more than a typical planet. But the very fact of the discovery proved that orphan planets really do exist. What lies within such worlds? At first glance, it seems that there is nothing alive there. After all, without a star, the surface quickly cools. But scientists speculate that life could hide deeper. Under thick layers of ice, an ocean, warmed by internal heat, may persist. We know that even in our solar system there are moons, such as Europa around Jupiter or Enceladus around Saturn. There too, it's dark, but beneath the ice, geysers gush, and the oceans remain liquid thanks to energy from the interior. If such a thing is possible here, then why not on orphan planets? Imagine this world. On the surface, it's eternal night. The stars are barely visible in the distant sky. Winds slowly move the clouds of the underworld, and in this silence, a cold reigns. But deep beneath the ice, a dark ocean retains its warmth. Creatures that have never seen light could swim there. They know no day or night. They don't need sunlight. Their life is sustained by chemistry, heat, and their own equilibrium. To us, such conditions seem impossible, but for the universe, this is just one of many scenarios. Science is moving forward. Projects are already underway to find even more wandering planets. One of them is called Cleopatra. The idea is simple. Place a spacecraft in space and observe the smallest fluctuations in the light of distant stars. If an invisible planet passes between us and a star, it can be detected. Perhaps this is how we will learn how common these cold wanderers are. Scientists speculate that our galaxy may contain hundreds of billions of such worlds. Think about it. This means that every step, every thought, every glance at the night sky is accompanied by awareness. Somewhere out there, in the darkness, entire planets are floating. They are no smaller than Earth, but devoid of a star. They are eternal travelers, wandering alone. The fates of these orphan planets vary. Some will wander forever, cooling and turning into icy rocks. Others will one day be drawn into the gravitational field of a new star and find a new home. Still others will be swallowed up by black holes, but for most, their lives are an eternal journey through the cold void. These planets remind us that the universe does not always operate according to familiar laws. We are accustomed to warmth and light, but in space there are other forms of existence. Even in the cold and darkness, a mystery may lurk. And one day, we may discover that it was on such planets that life, unlike that on Earth, arose. Chapter 5. Worlds of other stars. When we talk about planets, the first thing that comes to mind is our solar system. 8 worlds, each with its own history. Rocky Earth, giant Jupiter, cold Neptune. But the further we look into space, the more we realize that such systems are not at all unique. Every star can have its own planets. And today we know of thousands of such worlds. They are called exoplanets. Until recently, the very idea of planets around other stars seemed like science fiction. But at the end of the 20th century, astronomers first discovered signs of distant worlds. Since then, their list has grown at an incredible rate. We have learned to detect the barely noticeable wobble of a star when a planet passes close to it. We detect a small eclipse when a celestial body briefly blocks its light. These methods have opened up a whole universe of new worlds. And these worlds are astounding. There are so-called super-Earths, planets larger than our own, but also rocky. They may have a thick atmosphere and seas swept by hurricanes or, conversely, perpetual calm. On some, the temperatures allow liquid water to exist, meaning such worlds could be habitable. There are oceanic planets, completely covered in water. Imagine a globe without a single continent, only an endless ocean. Waves rise higher than the mountains, underwater volcanoes heat the depths, and clouds of eternal storms hang above the surface. If life exists on such planets, it is surely hidden in the ocean, in its dark, mysterious depths. There are also hot Jupiters. These are giants that orbit too closely to their stars. Their orbits are so small that a year there lasts only a few days. They are white-hot. Their atmospheres swirl with gas flows, and winds blow at 1,000 kilometers per hour. From the surface of such a planet, the starry sky is invisible. Everything is obscured by the blinding light of its sun. There are giant worlds that orbit so far from their stars that their surfaces are covered in eternal ice. And there are planets in binary systems, where 2 suns shine in the sky at once. Imagine a sunset, when 2 fiery disks disappear behind the horizon almost simultaneously. We are accustomed to seeing such images in movies, but in space, they are real. Scientists pay special attention to planets in the habitable zone. This is the region around a star where it is neither too hot nor too cold. Liquid water can exist there. We call water the source of life because it is what gave rise to all life on Earth. And if water exists elsewhere, then life could arise there too. Today, many candidates for the role of a second Earth have already been discovered. Among them are planets around Proxima Centauri, around the star Trapistis, and around distant red dwarfs. They are all different. Some are slightly cooler, others hotter. But there is a key element to their existence. We already know that Earth is not unique. Worlds similar to ours exist throughout the universe. Of course, they are very far away. Even the closest ones are several light years away. For us, this is a distance that is currently impossible to traverse. But the very idea that such planets exist is inspiring. Imagine that one day humanity sends a ship to one of these exoplanets. The journey will take hundreds or thousands of years, but at the end, a new world awaits the travelers, with oceans, mountains, and skies that human eyes have never seen. Perhaps there will be its own plants, its own creatures, its own history. Exoplanets remind us that the universe is not limited to our solar system. Out there, billions of kilometers away, other homes are hidden. Some of them are harsh and inhospitable, but others may prove to be new havens for life. When we look at the stars, we realize that almost each one could contain its own world. And this knowledge makes the cosmos even more vibrant and rich. After all, every point in the sky is not just a light, but perhaps an entire planetary system with its own secrets. Chapter 6: The Milky Way and its galactic neighbors. When we look up at the night sky, we see a bright band stretching from horizon to horizon. It resembles a river of radiance, in which millions of stars dissolve. This is our galaxy, the Milky Way. From Earth, it appears only as a hazy trace, but in reality, it is a vast island of stars, gas clouds, and invisible darkness, home to our Sun and billions of other luminaries. The Milky Way is our home in space. Its disk stretches for hundreds of thousands of light years. Its hub is filled with billions of stars, each of which may have its own planets. Somewhere among them, there are surely worlds similar to Earth. But from our perspective, it all merges into a silvery band, a reminder that we are part of something colossal. The structure of the galaxy is astonishing. It has a thin disk where the main stellar arms are located and a bulge in the center, which astronomers call the bulge. There, in the very heart of the Milky Way, hides a supermassive black hole. Its mass is millions of times greater than the Sun. We cannot see it directly, but we know of its existence from the motion of stars, which orbit an invisible point at incredible speeds. Our Sun is located on the outskirts of the galactic disk, approximately halfway from the center to the edge. It is a quiet place, where stars are not too densely packed. Thanks to this, Earth has had enough time for life to arise and develop. If we were closer to the center, then powerful radiation and constant catastrophes could make our world uninhabitable. But the Milky Way is not the only island in space. It has neighbors. The most famous is the Andromeda Nebula. It is located approximately 2 million light-years from us and is the nearest large galaxy. From Earth, it can be seen as a tiny spot in the sky. But if we get closer, a gigantic spiral with hundreds of billions of stars will unfold before us. Scientists believe that in a few billion years, the Milky Way and Andromeda will collide. It will be a majestic event. Two enormous galaxies will merge into one. The stars will barely collide with each other, because the distance between them is enormous. But the shape of the galaxies will change, and a new stellar world will emerge. There are other neighbors, too. For example, the Triangular Galaxy. It is smaller than the Milky Way and Andromeda, but is also a member of our local group. Its arms are filled with regions where new stars are being born. Enormous nebulae shine there, like cosmic flowers, illuminated by hot stars. Dwarf galaxies also circle the Milky Way. They resemble tiny satellites, consisting of several million stars. Sometimes their shape is distorted by the gravity of our galaxy. Some of them are almost completely destroyed, and their stars are stretched into long streams, like rivers of light encircling our home. One such satellite is the Great Magellanic Cloud. It is visible even to the naked eye in the southern hemisphere. It is an entire small galaxy, which also contains giant stars and clouds in which new worlds are born. For example, there is a star there whose mass is hundreds of times greater than the Sun. It shines so brightly that it illuminates entire regions around it. All these neighbors, together with the Great Magellanic Cloud, make up the local group of galaxies. It can be compared to a small family with three large members: the Milky Way, Andromeda, and Triangulum, and dozens of tiny galaxies circling around them. This family, in turn, is part of an even larger association. The Virgo supercluster. It contains thousands of galaxies connected by invisible threads of gravity. Imagine this. We live on a small planet orbiting a star. This star is on the outskirts of a vast galaxy. The galaxy is part of a local group, which is part of a supercluster. And there are countless such superclusters in the universe. Every time we expand our view, we realize the scale of the cosmos amazes and inspires. But let's return to the Milky Way. For us, it is not only home, but also a mystery. We still don't know its exact mass. We no longer see part of it, because it is hidden in the form of dark matter. This invisible substance surrounds the galaxy, holds its stars together, and gives it structure. We know of its existence only because it influences the motion of the stars. Every time we look at the night sky, we see more than just lights. We are looking deep into our galaxy. Some of these stars are very close, while others are so distant that their light has traveled for thousands of years to reach us. This means that when we look at them, we are looking into the past. The Milky Way and its neighbors are a reminder that we are part of something vast. It's as if we live in a small village on the shores of a vast ocean, where every distant light is a new island. And although we can't yet reach them, the very idea that they exist makes our journey through the universe even more wondrous. Chapter 7. Black Holes, Masters of Gravity. There are objects in the universe that are both frightening and fascinating. They are invisible, yet their influence can be felt over vast distances. In their presence, familiar laws cease to apply. These are black holes, the most mysterious masters of gravity. What are they? The simplest way to imagine a black hole is as a region of space where the force of gravity is so strong that nothing, not even light, can escape. If you were to stand near such a boundary, you would see only darkness, consuming everything around you. This boundary is called the event horizon. Beyond it there is no return. Everything that crosses it disappears forever. How do black holes form? The most well-known way is the death of a massive star. When the giant burns out and its fuel reserves are exhausted, the outer layers are blown outward in a supernova explosion, and the core compresses to such a density that nothing can stop its collapse. This is how a black hole is born, an invisible monster hidden in the darkness. But this is not the only possibility. Scientists speculate that at the very beginning of the history of the universe, primordial black holes, tiny the size of a mountain or even smaller, may have appeared. They formed from condensed matter in the first moments after the Big Bang. Such objects may still be lurking somewhere in space, but they are almost impossible to detect. There are different types of black holes. There are stellar ones. They are born from dying stars and are usually several times heavier than the Sun. There are supermassive giants, true giants, hidden in the centers of galaxies. The mass of such monsters can be millions and even billions of times greater than the Sun. This is precisely the kind of black hole that lives at the very heart of the Milky Way. It controls the motion of the stars around it, like a conductor of a cosmic orchestra. There are also intermediate versions. We are only now beginning to discover them. How can we observe something that is, by definition, invisible? The secret is that a black hole reveals itself through everything that falls into its trap. When gas or stellar matter swirls around it, it forms a bright disk. This matter heats up to millions of degrees and begins to glow before disappearing beyond the event horizon. This is how we detect the presence of a black hole, by the glow of its accretion disk. Sometimes, a black hole can have a stellar companion. Then its gravity gradually pulls matter from its companion, as if stealing its life. These streams of hot gas create fiery arcs that can also be seen in a telescope. But the most astonishing thing isn't the light or heat. Black holes distort space and time itself. Imagine that time moves more slowly near them. To a distant observer, an object falling into a black hole appears to freeze at the edge, never quite crossing the boundary. But for the object itself, everything happens instantly. This paradox forces us to reconsider our usual understanding of reality. The human imagination often depicts black holes as cosmic vacuum cleaners that suck in everything around them, but in reality, they are not so terrifying. If the Sun were replaced with a black hole of the same mass, the Earth would continue to rotate in its previous orbit. We would not notice the difference, except that it would become dark and cold. The danger arises only when we get too close. There are even more fantastic hypotheses. Some scientists suggest that black holes may be gateways to other worlds, or even tunnels to other parts of the universe. Such ideas sound like the plot of a science fiction novel, but for now, they are just beautiful theories. The history of black hole research is an example of how science moves from conjecture to discovery. Even in the last century, many considered them an abstract idea, a figment of the imagination, but now we have proof of their existence. In 2019, humanity saw for the first time a photograph of the shadow of a black hole at the center of the galaxy Messier 87. This image spread around the world, a dark circle in a shining halo. It was like confirmation that the myth had become reality. Today, astronomers are detecting gravitational waves, a wave of space generated by the collision of black holes. These vibrations reach Earth after millions of years and are detected by sensitive instruments. Thus, we hear the echoes of cosmic catastrophes that occurred in the depths of the universe. Black holes are not only a threat, but also a source of inspiration. They remind us of the limits of human understanding. We can describe their formulas, we can build models, but we are not yet able to comprehend the inner essence of these objects. Inside the event horizon, familiar laws cease to apply. There begins a realm of the unknown, where mathematics and physics are powerless. And there is beauty in this. Black holes remind us that the universe is infinitely deeper and more complex than we can imagine. Every time we look at the sky, somewhere hidden there are these masters of gravity. We cannot see them, but we know they are there. And perhaps they hold the most important secrets of the universe's structure. Chapter 8. Beyond the Universe. We've already come a long way, leaving behind the solar system, seeing our closest stellar neighbors, meeting giants like Betelgeuse and lonely wanderers, wandering without a star. We've crossed the Milky Way, peered into other galaxies, and even come face to face with black holes. But now we face the most difficult question. What lies beyond the universe? When we say the word universe, we mean everything that exists, all the stars, galaxies, planets, nebulae, light and darkness. But even this all has its boundaries. Scientists call it the observable universe. This is the piece of space from which light has managed to reach us over the entire existence of the world. Its diameter is tens of billions of light years, a vast number impossible to imagine. But what lies beyond this boundary? Here begins the realm of conjecture and hypothesis. We know that space is expanding. This discovery was a true revolution. Just last century, people believed that the universe was static, but observations have shown that galaxies are receding from each other, like points on an inflating balloon. The farther an object is, the faster it moves away. And there is a limit beyond which the speed of recession exceeds the speed of light. We will never see those worlds. They are receding faster than any particle can move. Beyond this horizon, there may be galaxies like ours, or entirely different forms of matter. But we cannot yet verify this. For us, they remain in eternal darkness. One hypothesis suggests that our universe is only a part of something larger. It is called a metagalaxy. Other regions may exist, separated from us by invisible walls of space and time. Each of them may live by its own laws. In some places, light is faster or slower. In others, matter is structured differently. And in others, neither time nor space as we know it exists. There's also a bolder idea, The theory of multiple universes. Imagine a foam of soap bubbles. Each bubble is a separate universe, closed and inaccessible to its neighbors. Our world is just one of them. Other bubbles may have different laws of physics, different stars and planets. Perhaps there is no light at all, or time flows backwards. It all sounds like fantasy, but such hypotheses help science explore new avenues. There are also philosophical ideas. Some scientists and thinkers suggest that the universe may be an illusion or even a complex simulation. If so, then beyond it there may be a reality we are unable to perceive. Just as dream characters cannot understand who is seeing them, so we cannot transcend the boundaries of our own world. For the average person, all this may sound terrifying. But there is also beauty in these thoughts. After all, the very fact that we ask such questions already makes us special. We are part of the universe, but we can think about what lies beyond it. Of course, until we have the tools to test these hypotheses, we can only build models, look at cosmic radiation, at the movement of distant galaxies, and draw conclusions. But science advances, and every year brings discoveries we couldn't have previously even dreamed of. Who knows, perhaps one day we'll be able to peer beyond the visible. For now, we can only imagine what lies beyond, an endless void or new worlds, silence or an endless chorus of galaxies. Perhaps our universe is just a tiny part of something much greater, and we can't even imagine how vast this cosmic ocean is. When a person looks at the stars, they are always searching for answers. But sometimes, it's not the answer that's more important than the question itself. The question of the boundaries of the universe reminds us that we live in a world of mysteries. And even if we never know the whole truth, the search itself brings us closer to understanding. Thus our journey ends. We have traveled from familiar planets to the darkest and most distant realms, and in the end, we have arrived at the boundary beyond which the unknown begins. And this unknown is the greatest miracle. Thank you for spending this time with me. Don't forget to subscribe to the channel so you don't miss any new lectures. Good night and sweet dreams.